Question 2. We've got In a Hurry, and he's off to buy some presents on Black Friday. And so he's going to park his new car. Let's make it a truck. Let's make it the Taco. There it is. He's going to park his car 80.0 meters away from the store. I'm going to make my store Best Buy, where I went the other day. It was a little crazy, 80.0 meters. And his velocity, my velocity, I suppose, I'm in a hurry, running, was 9.50 meters per second. All right, perfect. So how are we going to solve this? What are we looking for? We're looking to find out how long did it take me to get there? All right, so let's use the basic formula we've been using all along of distance is equal to, whoops, sorry about that. Velocity is equal to distance over time, all right? And I want to solve for time, so I need to isolate time. So let's go ahead and multiply both sides by time, like that. And I'm going to get that time times velocity is equal to distance. And then I will divide by velocity. And I'll end up with time is equal to distance divided by velocity. And that's what I want to plug my numbers into right there. All right. So time is equal to, what's my distance is 80.0 meters. And my velocity is 9.50 meters per second. All right. And so meters cancel. And my time, I'm going to be left with seconds. And if I pop that in the calculator, which I did already, I get 8.421 seconds. And that's what time is equal to. But I need to think about those sig figs. All right, so how many sig figs are in 80.0? 1, 2, 3. How many are in 9.50? 1, 2, 3. So my final answer needs to have 3 sig figs, which is going to be 8.42 seconds. And there's my answer. Whoops. The big reveal, 8.42 seconds. There you go. Okay, just so you're clear, again, a quicker way to find that formula that we're using here of time is equal to distance over velocity is to use the triangle method I was showing you in class. Take your thumb and cover what you don't have, right? Hey, there it is. Cover the time, and you're left with distance divided by velocity equals time. Okay. Question 3. Leatherback sea turtles can swim at an average of 10 meters per second. One morning, Crush decides to chase his friend Little Blue. Starting from a speed of 0 meters per second, he takes off. He catches up with Little Blue in exactly 8.4 seconds. Question A. What was Crush's final speed when he caught up to Little Blue? So we are trying to solve for velocity final. We don't know what that is. We do know that his initial speed is 0 meters per second. The question also tells us that his time is 8.4 seconds. Let's draw a little picture. Here's my turtle, because turtles are hard to draw, and he's going to catch up with the fish over here. He's got to travel that distance. The distance, we don't know what it is, but we do know the time equals 8.4 seconds. And that's great. Here's a nice little example of a question that gives you information that you don't actually need to solve the problem. The problem is asking you what his final velocity is, and we don't know what that is. We do have his average velocity, which I forgot to write down. His average velocity is 10 meters per second. So how can we calculate the final velocity given that we have the initial velocity and the average velocity? Well, let's look at the equation for average velocity. Average velocity is equal to the initial velocity plus the final velocity divided by 2. Just like you would find the average of any numbers, if you had a set of numbers, you would add them up and divide by the amount of numbers that you have, and you get the average. Well, we don't want to find average velocity. We have that. We want to find final velocity. So let's see if we can isolate final velocity before we start plugging numbers in. The first thing I'm going to do is multiply both sides by 2, and therefore those cancel. And so I'm going to end up here with 2 times the velocity average is equal to the initial velocity plus the final velocity. Okay, Now, all I need to do to get our final velocity all by itself again is subtract initial velocity. And that's going to give me 2 times the velocity average minus velocity initial equals velocity final. So I'm going to rewrite that over here so it's a little bit easier for me to see. VF equals 2 times velocity average minus velocity initial. And that's the equation we're going to use. So let's plug in some numbers. We're going to say that velocity final equals 2 times the average velocity, of 10 meters per second minus the initial velocity of 0 meters per second. All right, so our final velocity is equal to 2 times 10, which is 20, minus 0, which is 20 meters per second. That means that Crush is traveling at a speed or a velocity of 20 meters per second when he catches up with Little Blue. How about question B? What movie are they from? It's Finding Nemo. Come on. All right, question 4. Mr. Daly was driving on the highway at a speed of 26.8 meters per second. And over a period of 3 seconds, he sped up to 30.4 meters per second to pass another car. What was his acceleration? All right, so here's my taco. Drawing is not all that great today. And the initial velocity is going to equal 26.8 meters per second. And I'm going to be driving for a period of 3 seconds. And the final velocity is 30.4 meters per second. And I want to find the acceleration. So the formula for acceleration is going to be change in velocity over change in time. So the first thing I need to do is figure out the actual change in velocity. How am I going to do that? Well, the change in velocity is always going to equal the final velocity minus the initial velocity. So my change in velocity is going to equal 30.4 meters per second minus 26.8 meters per second. All right, and so if I do that, my change in velocity is going to equal 3.6 meters per second. Now, I need the change in velocity over the change in time. So let's move this up a little bit so you can see. And we're going to say that the change in velocity is equal to 3.6 meters per second. And the change in time is going to equal, 3 seconds. And therefore, the acceleration is going to equal 1.2 meters per second squared. Okay, for the second part of the problem, what we need to do is convert the final speed, the passing speed, from meters per second to miles per hour, and we're going to use dimensional analysis to do this. So I set it up for you. I'm just going to walk you through it to show you how this works out. So our final velocity is going to be 30.4 meters per second, and I'm first going to attack the dimensions of distance. And so meters, right, 1,000 meters will go to 1 kilometer, so those can cancel. 1 kilometer actually will equal 0.621 miles, and I got that figure from the back page of my notebook right here with these, the conversion information, multiplication tables and all that. There it is, I put a little dot next to it. 1 kilometer is equal to 0.621 miles. So again, now my kilometers cancel, and I'm left with the correct unit of distance that I want, which is miles. Moving on to the dimension of time, I've got 60 seconds in 1 minute, so seconds cancel. In 1 minute, in 60 minutes, that would be 1 hour, so now my minutes cancel, and I'm left with the correct unit of time, hour. I'm left with miles per hour. So if you multiply across and divide by the bottom, you're going to come up with the passing speed was 67.96 miles per hour, which I rounded to 68 miles per hour. Don't forget, we need to figure out how fast over the speed limit I was traveling when I made that pass. So my passing speed was 68 miles per hour, and the speed limit was 65 miles per hour. Therefore, I was traveling at 3 miles per hour over the speed limit. My dog is trotting at a leisurely pace of 1 meter per second. Suddenly, he spotted a rabbit just beyond the split rail fence in the backyard. Murdoch then accelerated after the rabbit at 6 meters per second squared. The squirrel ran up a nearby oak tree. It took Murdoch 4 seconds to get to the tree, And it says for a hint, let's start with the formula for acceleration. So I'm going to write that down over here first so I have it. Acceleration is equal to the change in velocity over the change in time. And I'm not going to draw a very detailed picture for this particular problem. Instead, I'm going to start by organizing the information, the given information, and what I'm looking for. So, do I have the initial velocity? I do. That is going to be 1 meter per second. I don't have final velocity. I don't have average velocity. Do I have acceleration? I do. That's going to be 6 meters per second squared. Do I have the distance? I do not. How about time? I do have time. Time is equal to 4 seconds. And it says that we should start with this formula here. Acceleration is equal to change in velocity over change in time. So it looks like I've got acceleration and I have time, and I could certainly use the change in velocity. So I'm going to isolate that, and I'm going to do that by multiplying both sides by change in time. Let's do that. And those cancel. And so I'm going to get the change in time times A is equal to the change in velocity. And now I can plug in my numbers. The change in time is going to be 4 seconds. The acceleration is going to be 6 meters per second squared. And that will equal a change in velocity. And now this second cancels, and one of those seconds cancel. So my answer is going to be in meters per second, which is the correct unit for velocity. 6 times 4 is 24 meters per second, and that is going to equal my change in velocity. So if my initial velocity is 1 meter per second and it changes 24 meters per second, then my final velocity must be 25 meters per second. And that's the answer to question A, right? Question A says, what was his final speed? Well, it was 25 meters per second. Question B asked you to think about his average speed. So how do I find average speed? Well, remember that the velocity average is going to be the initial velocity plus the final velocity, all divided by 2. So can I do that? I certainly can. I can say that the velocity average is equal to 1 meter per second plus 25 meters per second divided by 2. So my average velocity is going to equal 13 meters per second. So 1 plus 25 is 26 divided by 2 is 13 meters per second. And that's going to be the answer to problem B right there. So we're moving right along. Let's look at problem C. Now, problem C asks us to think about how far did he travel, okay? Well, what formula could we use to do that? We've been using velocity is equal to distance over time. And so we can rearrange that to solve for the unknown value of distance. And this time I think I'm going to use the triangle that I've shown you. Velocity is equal to distance over time. And I want to find out the velocity, so I'll cover that up. And I know that if I multiply and again, this is the average velocity that we're talking about, which we've just solved right here. If I take the average velocity and multiply it by the time, I'm going to get the distance. And so that's great. So the average velocity is 13 meters per second. And I'm going to multiply that by the time, which is 4 seconds. And that is going to equal my distance. And once again, if we look at our units, seconds are going to cancel. So my final answer will be in meters, which is the correct unit I'm looking for. And 13 times 4 is going to be 52 meters is equal to the distance. So my man Doc ran 52 meters after that squirrel, which he never caught.